Heliae is a Gilbert-based algae technology company that recently reached a deal with a Dutch firm to turn the gooey mess found at the bottom of dirty swimming pools into aviation fuel to fly people around the world. Here to talk about his company and the use of algae for jet fuel is Dan Simon, President and CEO of Heliae. Good to have you here. Thanks for joining us.
Thank you very much.
Did I get it right? That's pretty much what Heliae does.
That's
Develop
what we
algae.
do. Yeah.
For what? For not for jet fuel and other things as well?
Yes, we're growing algae to make foods and fuel and chemicals.
Describe this deal now with this Dutch firm. What's going on here?
So Sky Energy is focused on finding options for the aviation industry to offer products beyond petroleum-based aviation fuel. So they've set up partnerships with a number of other suppliers, palm oil as an option, camelina, jatropha, and algae, and we're the first true algae producer, signing up with them to sell a jet fuel to the aviation industry.
How far along is algae-based jet fuel technology?
Algae-based jet fuel technology, in our perspective, and I can only give you our own, but it is anywhere from 3 to 7 years, depending upon capital investment, because the key challenge right now is scaling it up.
So 3 to 7 years before it's cost competitive?
Yes.
Or what about supply? Able to supply what is needed?
Think about it like this. There's 150 billion gallons of, just take transportation fuels in general in the United States. We're only trying to make 1 billion gallons to start with.
Yeah.
It'll be years before you get to a point where you actually make a huge dent. But what we're looking for are options here, and it's going to grow slowly.
Talk about why it has grown slowly, or whatever pace it has grown. I mean, this seems like it should be. Algae itself seems like it grows exponentially. Why is this not? Why are we just now finding out about this?
That's actually a really good question. I'd probably start with Saudi Arabian oil. It costs $19 to pull it out of a hole. And then go to tar sands, okay? And the tar sands, it probably costs them about $38 to $39 per barrel to pull it out of the tar sands, the process. Same issues with renewable fuels, okay? Just go up the cost path, okay? If it's cheap, you're gonna look for the easiest way to produce it, and that's petroleum. Now we all recognize that it's starting to disappear. We're not gonna have enough in 50 years from now. You have to look for options. Algae is no different than any other renewable fuels. Corn and sugar were the easiest to make renewable fuel out of, but people recognize there's challenges to it, food versus fuel and demand. So algae is just farther down the path.
And you've got some examples here, some samples I should say on the desk. What are we looking at here? And explain quickly, if you could, how algae becomes oil and protein and diesel fuel and all sorts of stuff.
It's an incredible plant. It's one of the oldest chemicals we have and biomass products we have in the world. This is algae in its biomass form once it's dried. This is algae oil. So once you harvest the algae, you separate it out and you create an oil product. And think of this no different than you would crude oil, okay? And then you take it to a refinery and you start breaking it up into pieces so you can make different types of high protein products out of algae. This is omega-3 or like fish oil.
Sure.
And then you make diesel and jet after processing it.
So basically you can do a whole bunch with not a lot of algae.
It's a very flexible process. It's also a flexible product.
How much algae do you need to get a serious crop going, and how long before the algae turns into those vials?
Well, what I can tell you is, and I'll compare it to corn. Corn has a harvest once every depending upon what kind of corn you buy, anywhere from 80 days to 130 days, okay? This we harvest every 6 days because it populates so quickly. Granted, it's a lot smaller, but it takes about anywhere from 6 to 24 hours, depending upon the species of algae you're working with, for it to double.
My goodness.
So, you know, to ask how big is a commercial plant, that's what I get that question a lot.
Yeah.
For a fuel-based plant, to be able to produce it at that cost, which is a much lower cost than a high protein or high food product, is going to take you anywhere from 300 to 1,000 acres at current technology. For a food-based plant, it'll take anywhere from 5 to 10 or 15 acres.
Wow. Okay, so where do we go from here? You got this deal. This is kind of a development deal, I would imagine, with this Dutch firm.
Yeah, it's a partnership.
Where do we go from here with this?
We continue to work with them. We're going to sell them our first barrel of oil of jet fuel. We'll probably deliver it to them sometime in February or March is what we're targeting right now.
Okay.
And we'll continue to work with them in the European community.
And real quickly, your relationship with ASU, Science Foundation of Arizona, got to be big.
It's very important. I mean, without Science Foundation of Arizona and our relationship with ASU, we probably wouldn't have targeted the company here. Although Arizona has everything you need from a climate and land perspective, all we need is sun and CO2 to make the stuff. But having Science Foundation Arizona there and ASU's technology, we were able to kind of make the point of, okay, we'll build a headquarters right here. Science Foundation of Arizona contributed to ASU in partnership with us to go ahead and do the basic research to develop the strains to make the algae.
Well, very good. It's good to have you on your show. Continued success, and we'll look forward to hearing some more news in the future.
Thank you very much.